Let us see how to solve a differential equation using method of variation of parameters. So first we need to find the solutions of the corresponding homogeneous differential equation. For example, here if I take this differential equation, what is the corresponding homogeneous differential equation? Which is d square plus 1 of y equal to 0. So we will write the auxiliary equation. So the auxiliary equation is r square plus 1 equals 0. Therefore r equals plus or minus I. These are the roots. Or in other words, you can write r square equals -1, and from that you can get r equal to plus or minus I. So you got complex roots. When you get complex roots, what is the complementary function? So suppose if the roots are a plus or minus ib, then this is how we write the solution: e power ax into c1 into cos bx plus c2 into sin bx. Okay, but here a is 0 and b is 1, so we can write here c1 into cos x, because b is 1, plus c2 into sin x. That's it. So now the two solutions of the corresponding homogeneous equation are: one is y1 equal to cos x and y2 is sin x. So now after this, what we have to do is we need to find the Wronskian of y1 and y2. So the Wronskian is defined like cos x and sin x. It means y1 and y2. Okay, let me write the formula first. So y1, y2, and you write its derivatives, y1 prime and y2 prime. So here in our case, y1 is cos x and y2 is sin x, and here you can write the derivative of cos x, which is minus sin x, and derivative of sin x is cos x. And if you take the determinant is cos square x minus into minus plus sin square x. And we know the cos square x plus sin square x is 1. Therefore, the Wronskian of y1, y2, which is nothing but 1. And here in the given function, you see what is the coefficient of d square, so that is 1. Okay, if the coefficient of d square is 1, we can directly take the right hand side function as f of x. Okay, or f of x or g of x, whatever we assume. So let me take g of x is equal to cosecant x into cot x. So now let us write formula for variation of parameters. So now we are going to write particular integral. So as a of x into y1 plus b of x into y2. Okay, so where a of x is given by this formula. So a of x equal to integral minus y2 times of g of x over Wronskian of y1 y2 into dx. So this will be integral minus, here what is y2? If you observe that our y2 is sin x, so we need to substitute here. So sin x into g of x. G of x is nothing but cosecant x into cot x over 1, because the Wronskian is 1. Now I hope you can cancel this sin x and cosecant x, and what you have is minus of cot x. You have minus of cot x, and you know that this cot can be expressed as a cos over sine, and the derivative of sine is cos x, which is there in the numerator. Therefore integration will be ln of sine x. That's it. So this is what a of x. So we got a of x. Next we need to find b of x. So here b of x equal, the formula is integral y1 into g of x over Wronskian of y1 comma y2 into dx. So this equals, what is y1 here? Y1 is nothing but cos x, and g of x is cosecant x into cot x over 1 into dx. And I hope you can see that this becomes, this cos x into cosecant x, it becomes again cot x. So on cot x into cot x, finally it becomes cot square x into dx. Okay, because cosecant x is 1 by sin x, so cos x by sin x becomes cot x. And you know that this cot square x can be written as cosecant square x minus 1, right? So this one can be written as cosecant square x minus 1 into dx. And we know that the integration of cosecant square x is minus cot x, and here it is negative x. That's it. So this is what b of x. So now we got a of x and b of x. Now using this, so we can write what is yp. So therefore the particular integral is, the formula is this one, right? A of x into y1 plus b of x into y2. It means, what is a of x here? Minus ln of sin x. Okay, this is a of x into y1 is actually cos x, plus b of x is minus cot x minus x into, this is sin x, that is y2. So maybe if we simplify this, finally we can get the particular integral minus cos x into ln of sin x, and this is minus of this is cot x into sin x, that becomes cos x, which is cos x minus x into sin x. That's it. So this is the particular integral. So now if you want the general solution, therefore the general solution is y equal to yc plus yp, and you know that is c1 into cos x plus c2 into sin x, and plus you need to write the other, that is minus cos x into ln of sin x minus cos x minus x sin x. That's it. So this is how we can find the general solution of the given differential equation using method of variation of parameters. So the main important thing is you need to remember these two formulas. Okay, here for a of x you'll get minus, and this will be y2. Okay, for the a you'll get 2, and for b you will get 1 here. So keep it in mind. Okay, suppose here in the given problem, instead of having d square plus 1, suppose if you have d square plus, let's say 9. Okay, if it is d square plus 9, yeah, accordingly here you'll have 3 cosecant 3x and cot 3x. Yeah, then what happens, while finding roots you'll get 9 here. Yeah, so you'll get minus 9 here, so plus or minus 3i you will get. In that case you'll get cos 3x sin 3x. Okay, cos 3x and sin 3x. And what happens to the Wronskian in that case? So this will be cos 3 sin 3, and this will be minus 3 sin 3x and 3 cos 3x, right? So in the Wronskian you'll get 3 times of this, 3 times of this. Finally, you'll get 3 as the Wronskian. Okay. So be careful. If you have some different number here, then you'll get the different quantity, right? So I hope you understand. And okay, if you want to see a problem like which do not get this cos x and sin x, okay, I'll do one more problem similar. I mean, which do not involve this cos x and sin x. Okay, just a minute. Yeah. So here is a problem, y second derivative minus y equal to 2 by 1 plus e power x. So we need to solve it using method of variation of parameters, right? So here it is easy to see that the auxiliary equation, that would be r square minus 1 equal to 0. Therefore it can be written as r minus 1 times r plus 1 equal to 0. Therefore the roots are plus or minus 1. So what would be the complementary function? C1 into e power x plus C2 into e power minus x. Okay, maybe let me write minus first, plus next. So therefore, what is y1 now? Y1 is going to be e power negative x, and y2 would be e power x. So now you may look for the Wronskian of y1 and y2. I'm directly writing this is e power negative x and this is e power x, and minus of e power minus x, because derivative of e power minus x is minus of e power minus x, and here it is e power x only. So now if we take the multiplication, this is e power x into e power minus x, and minus into minus, this will be plus e power minus x into e power x. I hope e power x into e power minus x, that becomes 1. So 1 plus 1, so finally you got 2. Okay, so this is the Wronskian. Now we need to find a of x and b of x, right? So let me write what is g of x here on the right hand side expression, which is 2 over 1 plus e power x. So let's find a of x now. So a of x is nothing but integral minus y2 into g of x over Wronskian of y1 comma y2 into dx. So which is integral minus y2, it means e power x here, and g of x is 2 over 1 plus e power x whole divided by 2 into dx, because the Wronskian is 2. So this one I hope I can rewrite it like this. 1 by 2 I'll take it out. So this becomes minus 2 into e power x by 1 plus e power x into dx. Now I can simply integrate it. So if you integrate this 2 you can cancel, and minus of derivative of denominator is there in the numerator. Therefore integration will be ln of 1 plus e power x. That's it. So we got a of x. And now you go for finding b of x. What would be b of x now? Integral y1 into g of x by Wronskian of y1 comma y2 into dx. So this will give me integral y1, it means e power minus x here, and g of x, you know, that is 2 over 1 plus e power x by 2 into dx. I hope we can cancel 2 on 2, and here what you have is e power minus x over 1 plus e power x into dx. Okay, now we need to think about its integration. Now we can actually rewrite it like this. Integral in the denominator, you do one thing, take e power x out. So in the denominator, if you take e power x out, I hope we can rewrite it like this: e power minus x plus 1. right? And the numerator you have e power negative x into dx. Okay, so I hope you can see what I have done. I have taken e power x common in the denominator. So the advantage in writing like this is, so you can actually write it like this. In the numerator you have e power minus x, right? So e power minus x, you add 1 and subtract 1, and in the denominator you have e power x times e power minus x plus 1 into dx. Okay, and this becomes integral. I hope you can separately write it, e power minus x plus 1 over, this is e power x times e power minus x plus 1. You can cancel them. Minus 1 over e power x into e power minus x plus 1 into dx. Okay, and this will be integral, what do you have, 1 by e power x after cancellation, minus, in the denominator e power x can be written as e power minus x over e power minus x plus 1 into dx. Okay, now it is easy to integrate because the first expression is e power minus x only, so its integration is minus of e power minus x, and the second expression, the derivative of denominator is there in the numerator exactly, so that will be plus ln of 1 plus e power minus x, that I can see. Okay, so therefore b of x, so here b of x is going to be ln of 1 plus e power minus x minus e power minus x, that's it. And what is a of x we got? A of x is minus, a of x is actually minus ln of 1 plus e power x. Okay, let's do one thing, let's try to write b of x in terms of e power x only. So for that, what we have to do is, you need to write it like 1 plus 1 by e power x, and you take LCM, this becomes e power x plus 1 by e power x ln of. So now you can write it in ln a minus ln b form, right? So therefore I'm directly writing here, this can be rewritten like ln of e power x plus 1 minus ln of e power x minus e power minus x. So now I hope we can write the particular integral. So a of x into y1 plus b of x into y2. So I'm writing directly. So y1 is e power negative x here, so e power negative x minus of ln of 1 plus e power x plus b of x is going to be this, and this should be multiplied with e power x. Okay, so this is e power x into ln of e power x plus 1 minus e power x into ln of e power x minus e power x into e power minus x, that becomes 1. That's it. So this is the particular integral. Okay, and finally you can write the general solution, right? So here if you observe that to integrate this guy, I have applied a small technique, like taken e power x out and simplified into this expression. Okay, so I hope you understand. Thank you.